Hello and welcome. I'm Major Nigel Bovey, Vice Chair of Christian Evidence Society. Welcome to Questions of Our Times. Today's question is, are we here by accident? As a 13-year-old, my guest today was so keen to be a scientist that, unusually for someone of that age, or maybe of any age, she started to read Albert Einstein's theory of relativity. The fact that she, like the famous physicist, is German might have given her an advantage. But it was, though, only after years of study that took her to Munich, Strasbourg, the CERN facility in Switzerland, Massachusetts, Manchester, and Tel Aviv, that she became Professor of Theoretical Physics at Darmstadt's Technical University. It's just a 3-hour drive from where Einstein was born. When she's not researching statistical physics and complex models, she likes to sing and play the piano, which is something of a complex model itself. And so to talk with me today about the physics behind the universe is Professor Dr. Barbara Drossel. Barbara, welcome. It's wonderful to see you.
Good evening. It's good to be here.
Good. Let's start, please, right at the beginning. First principles, Barbara. What is theoretical physics? It sounds very brainy.
You know, physics can be done in 2 ways. Either you can do experiments or you work with paper and pencil and computer. And I'm working with paper and pencil and computer, trying to build theories, to do calculations, to better understand what's happening in the experiments or in the observations.
So you're working with paper, you're working with pencil. I like the technology. That's my chosen instrument as well. Well done. What are you working on at the moment that you can actually share? You might be working on something very important that you can't share with us, but if it's something important you can share with us, what are you kind of looking at the moment?
So we have quite different types of projects in my group. Part of the projects are biological. We model biological networks, and at the moment we are modeling ecological systems, in fact. So a biological colleague of mine is studying the rainforest in Ecuador, how it recovers when plantations are returned to forest. And so we make models for how species come in and build a network and how this network is formed again. For instance, that's one of the projects. Another one deals with quantum physics, understanding how you can get from quantum behavior to classical behavior. You know, when you have just one atom, you describe it by quantum physics. When you have a block of material, you describe it differently. So how can you understand this transition from quantum to classical? That's also one of the questions we are dealing with.
Thank you. Now, just clarify for me, please. Quantum physics. It's to do with the elements, those little bits and pieces that make up molecules. Is that right? Or sorry, make up atoms. Is that right?
That's one very important application of quantum physics. So when you deal with the very cold or the very small, usually you need quantum mechanics. You know, particles are not points or just massive objects anymore. They are waves also. So you know about all these strange properties of quantum systems, like uncertainty, relation, and so on.
Okay, so within quantum physics, we'll probably touch on this a little later on. In quantum physics, we're dealing with uncertainty, are we? That's an element of quantum physics.
So to speak, yes.
Good.
I can explain more later, maybe.
Yeah, let's do that. Okay. Please, listeners, please send in your questions now so I don't have to get my head around quantum physics later tonight. Okay, Barbara, look, what inspired you as a 13-year-old girl to start reading Albert Einstein? It's not, I was going to say it's not normal. It's not usual, is it, for 13-year-olds to read Einstein?
I was not a usual girl, you know. I felt very different from everybody else, and that was a big problem for me, in fact. But I was fascinated by science and by the universe. And if you are interested in the universe and read about cosmology, you cannot do without Einstein. So I thought I want to learn a bit about his theory of relativity. In fact, I think with Einstein, I started when I was a bit older, maybe 15 or so.
Okay. Nevertheless, that's quite a young age to be interested in this. Now, Einstein is one of a number of scientists who have described the nature in terms of laws. Whether we're a scientist or not, we understand the concept of the laws of nature. What do you regard as the big laws of nature?
I don't know if there are big and small laws.
Mm-hmm.
I mean, certainly the important laws are those that we teach at university. So all of you have heard about Newton's laws, classical mechanics. We still teach this because it's very relevant for many, many applications. And there is electrodynamics, the laws describing electricity and magnetism and electromagnetic waves like light. Then there's quantum physics, where you deal with atoms, for instance. In order to understand the stability of atoms and the spectra of atoms, you need quantum physics. And there is quantum field theory, which is a version of quantum physics that was developed for particle physics, for particles, when also particles can be created and destroyed again. And then there is thermodynamics. That's a very interesting field of physics because it has the second law of thermodynamics, which tells you that entropy, or let's say disorder, increases in time when you have a closed system. So there is a direction of time in thermodynamics which is not present in other laws of physics. And that's a very, very interesting philosophical question. So, I consider thermodynamics very important.
Okay, well, let me just, on that second law of thermodynamics is an instance of that, and you're talking to a non-scientist here, it is an instance of that, things hot will, if left untouched, will go cold.
For instance.
Things cold, it's like a one-way street. Things hot will go cold if left untouched, but cold things will not warm up by themselves. Is that an instance of that law?
Yeah, if you put it more precisely, things will take the temperature of their environment if you leave them.
Right. Yeah. Okay.
Yeah. For instance, that's one very good example for the second law. Mm-hmm. And you know, this thing doesn't happen in the reverse direction of time.
Right. Okay. Yeah. So, for example, with gravity, it only goes downwards, doesn't it?
Yeah. You know, if you just throw a stone in a pond, it goes down to the ground. It never happens that all the molecules of the water just decide to push or together the stone and bring it up again. So that's also an instance of the second law.
Only when you reverse the film in the video.
And it looks very unrealistic. Yeah.
It does. Yes, that's right.
Is very important.
Now, thank you. You touched it in there on the quantum side. You did mention that it gets a bit interesting. Now, does it mean that, how fixed are these laws? We know, let's stay with gravity because it's something we all understand. I would suspect probably more easily, or we all know a little bit about gravity because that's literally what keeps our feet on the ground. The law of gravity, for example, is never going to change, is it?
No, I mean, it really depends on what you mean by fixed. Mm-hmm. They are fixed in time, so we can look back into the past when we look very far in the universe. And as far as we can see, the laws of physics have been the same and the constants of nature have been the same. Or if they have changed so little that we cannot see it. So in this sense, they are fixed. But if you mean by fixed that they will never be modified or a bit generalized, then I think they are also pretty fixed. If a law has been applied very, very often and it has been confirmed by many, many experiments and applications, you can say it will always be taught at school. And it might become a special case of a more comprehensive law. I mean, like classical mechanics is a special case of theory of relativity when velocities are much smaller than the velocity of light. But I would say laws are not fixed in the sense that they are not completely accurate. They are not an exact image of nature. They are an idealization. They are a simplification. They are a model that does not take into account everything, but some parts of nature that you want to describe.
So they're a best explanation. This is the best way that physics or scientists can explain a phenomenon that you observe in nature. So whether that's dropping a book onto the floor, somebody has observed that, somebody measures the velocity, and that is relative, well, that is fixed. I mean, there is a formula for the falling, whether it's a feather or an elephant, is there not?
But the feather falls much slower, and then you need this additional ingredient of, you know, the resistance of the air.
Yeah.
If your friction, and so when you have your mathematical formula and you do the measurement, often you get deviations, and then you need to think about, what did I not take into account in my calculation? Maybe friction, maybe wind, maybe magnetic effects, maybe whatever else.
So these laws then, which are a description, but are subject to what we might say refinement or improvement or further knowledge, do they actually, what do they determine about life?
About life?
Yeah, what you know, do they have some power to determine certain things about life?
I mean, I think I, as a human, as a living being, cannot do anything against the laws of nature, certainly. And in my cells, in my body, there happens nothing against the laws of nature. But I'm not fully determined by the laws of nature. So I like to quote George Ellis. He is a cosmologist who also got the Templeton Prize. And he likes to say that the laws of nature underlie everything. They enable everything, but they do not determine everything. And it's a bit like a computer. You know, you build the hardware of the computer so complex that the computer can perform any calculation, any possible calculation. Then the computer is called a Turing machine. So it must be complex enough to be useful for any type of calculation. And that's, I think, a good picture for how to understand physics. It's complex enough that even life is made possible, and even consciousness. So physics is the platform on which life and consciousness runs, but physics does not determine it. It enables it and provides all these possibilities for these things to happen.
Yeah. So the question for tonight then is, are we here, is human life, are we here by accident?
That's not a scientific question. That's a philosophical question. It really depends on how you interpret science. I mean, there are people who claim that we are here by accident because these people have a certain worldview. And this worldview can be, often is reductionism or materialism. When you believe that the laws of nature and chance and matter are the ultimate reality, which explains everything else and which brings about everything else. I mean, then we are here by accident, in the sense that there's nobody who wanted us to be here or who determined it beforehand. So, but if the worldview is that the ultimate reality is God, so that's what exists eternally by itself and what is the source of everything else, if that's a spiritual source, if it's God, then he wanted us to be there. He wanted the universe to be there. So then we are not here by accident. And I, as a believer, of course, believe we are not here by accident. And I think there are good reasons that one can bring forward to defend this view.
Would you like to offer a couple of reasons to defend that view?
I think, you know, just the phenomenon of consciousness can not be explained on a purely material basis, because, you know, science is always the objective view from outside. But consciousness is the subjective view from inside. So that's so fundamentally different. Science is objective and my experience is subjective, and it's I who experience it, and you don't know how I feel inside right now. So that's one reason why a purely materialistic description is not sufficient. And, you know, all these questions about meaning, about morality, they cannot be answered on a purely material basis. You need additional assumptions that in some sense are spiritual. And then all matter that we know of has come into existence and it will be destroyed sometime. I mean, the Earth has come into existence 4.5 billion years ago. It has not existed forever. We have not existed forever. So everything in this material universe has had a beginning and it has an end. So it cannot be the eternal foundation of everything else. And one more reason for me is, this longing for eternity, this, I would almost say, not knowing about eternity, but this longing for eternity, this feeling that there is more to life than just us being a bunch of molecules in a complex arrangement. This also hints at some deeper reality, some spiritual reality, yeah. And I think we'll get to more reasons during our conversation.
Of course. You mentioned there that the Earth had or the universe had a beginning. It wasn't always there. We have not always been here. Scientists offer us the concept of the Big Bang theory, or the Big Bang explanation, that suddenly there was nothing. There was nothing, and then there was something, and that's evolved to where we are today. Do you hold to that model? Do you think that's the best explanation we have at the moment of the origins of the universe?
Yes, I mean, we cannot explain the Big Bang itself in terms of science. We can only start physics once the Big Bang has happened and the universe is there, no matter how small it is initially.
Yeah.
So, the idea of the Big Bang was brought up by a priest, Georges Lemaitre. He was a theoretical physicist and a priest. And, those people who did not want to accept the Big Bang were atheistic scientists, because they wanted the universe to be eternal. But then, more and more evidence was found that the Big Bang theory, the Big Bang theory made predictions. For instance, the cosmic microwave background radiation. So if the universe was hot, very hot at some point in time, the rest of this hot radiation must still be here, but now the wavelength of the radiation has been stretched because the universe has expanded. And this radiation was found in the 1960s. And I think that was the point when most of the skeptics accepted the idea of a beginning of the universe. And then there are more reasons, but I think we don't want to spend all the time. Shall I give more reasons why people accepted the idea of the Big Bang?
Yeah, but today, I mean, it's interesting you say that at the beginning it was the atheistic scientists that didn't like the idea of a beginning.
Yeah.
Quite often today we hear voices from the Christian community that say, well, actually, we don't like the Big Bang theory because it goes against what the Bible says about God creating. Do you see any conflict in those two narratives, those two explanations?
No. It's so sad that this happens. And I don't understand. I mean, I know what those people think, but I think it's very sad that they think in this way, because they mix up different levels of explanation. When science deals with cause and effect, with mathematical laws that describe what happens in nature, and the laws of nature by themselves, in the Christian view, are the laws by which God sustains the universe. So even the laws are God's actions. So why should there be a contradiction between describing the universe in terms of science and God being the author? Do I have here a book? Oh, okay. No matter what it is Paul Feyerabend. So it would make no sense to ask, did Paul Feyerabend write the book, or was it printed in a printery, so in a printing shop? So
yes.
It's the same thing with the universe. Did God make it, or does the universe have a long evolutionary history? So different levels of explanation. I should not mix them up.
Yes. Okay. So we have a in the book, the Bible, the book of the book. We have an explanation or a narrative about how the universe came into being. We have the book of nature, which also says how the universe came into being, and they are the same story told in different ways, are they?
And it's different things are told to us. There are so many things that we need to know about the universe, and just the mathematical description is one thing, but the purpose and what it's for and who made it, that's the other thing. And if you read the first chapter of the Bible, I mean, it's not a scientific text, and it's a text that must have been understandable to the people who read it at that time. So they had a different worldview. And of course, the language must be such that everybody can understand it. And the message is God made the world for us, to give us day and night, the rhythm of day and night, and then the water, you know, the rain, the plants growing to feed us. That's what this text is about, that God provided for us, made a universe for us.
Some scientists suggest that life on Earth is possible only because of mathematical ratios and relationships. You know, the force of gravity as against the force of dark energy, gravity pulling us down, dark energy taking us away. They are different forces, but they are very, very finely tuned. If one was greater than the other, we'd either float off into space or we'd implode because we'd all crash. Now, can we conclude that if the world looks designed to be finely tuned, then there must be a designer?
That's a legitimate conclusion, but you don't have to conclude it. Mm-hmm. And maybe a bit more about this fine-tuning, because my favorite example is not really dark energy, because we don't yet understand it very well. So, but you know, this it's the electromagnetic forces, the nuclear forces also, and gravity, of course, because you know, for the universe to function in the way it does, you know, there must be the possibility that the stars can form, and then that nuclear fusion in the stars can create all the elements. And you know, when you do the calculation, you have a problem. How can you create carbon? Because it's very difficult to create enough carbon, but enough carbon was created, obviously. And this can only happen because there is what people call a resonance. So the reaction rate, the reaction between those atoms that you need to make carbon is only large enough when the electromagnetic and the nuclear forces have the right ratio. And this was really a surprising discovery. And so that's one of the many ways in which the universe is just made in the right way to make life possible, and all this complex chemistry and biology.
So you said there...
Oh, I didn't get answer your question, really. Sorry.
That's okay, go on. That's fine.
Thought. So I think, so even Fred Hoyle, who made this discovery, he was an atheist and he remained an atheist, but he said, it looks like it was done on purpose. And later he said, nothing shattered my atheism as much as this discovery. He still remained an atheist, and there are, you know, other options. You have heard about this idea of the multiverse. You know, there are many, many universes, and each one gets some random set of natural constants. And in some of the universe, the constants are just right to allow all this complex phenomena that we see in our universe.
So the concept of the multiverse is that just as there are a set of numbers, let's call it a combination, like a combination lot. There is a set of numbers that's just right that allows this universe and the planet Earth to exist, and for life as we know it to be coming to being. So there's a set of combination numbers for this universe. There could be other sets of other combinations that produce or unlock other universes. That's the idea of the multiverse, isn't it?
Yeah, there might be other combinations and you get another universe, but that's usually very boring. Yeah.
Yeah. How much of a serious scientific theory or idea is that, or is it a reason not to accept that this universe looks as if it's designed and looks as if it's meant on purpose, as Fred Hoyle says?
I think different people would give different answers, even different believing people, but I really would say multiverses were invented in order to evade this conclusion that it was done on purpose. So if you have this materialistic reductionist prejudice, then you search for a materialistic explanation, and then the multiverse is what you come up with. So I see no reason why we should postulate a multiverse, but if there was one, okay, then God would have created the universe generating mechanism that also creates our universe. So you still cannot get rid of the question whether there's somebody who figured it all out and who planned it.
So your logic is, if there is a God who is clever and skilled enough to make one universe, he is therefore clever and skilled enough to make more than one universe. Just like Stradivarius built more than one violin.
Yeah, maybe.
Yeah.
But,
maybe, okay.
But I think we only can investigate one universe, and so the natural assumption is there is this one universe. Beyond that, we know nothing.
Okay. What proof? We've touched on this in our discussion about fine tuning, but what proof can you offer for the existence of God, or if not proof, then evidence? How do you know there's a God? You've spoken quite a bit so far about there being one.
Yes, I think this question about the fine tuning, that's one of the arguments for God, and there are more questions of this type that are raised by science, but that science cannot answer. For instance, why are there laws of nature at all? Why does the universe obey these mathematical equations? And you know, the early scientists, they believed in laws of nature because they believed in a lawgiver. So for them, it was natural to assume that there exist laws of nature because they thought God is even a great mathematician. That's what Johannes Kepler thought. Yeah. And he wanted to create a universe according to perfect mathematical laws. That was his idea, and that's how he came up with his 3 Kepler laws. And then there's another question the science raises that goes beyond science is, why can we understand the universe? Now, Einstein wondered about this, and he said, the only thing that he cannot understand about the universe is that it is understandable. But again, for Kepler, this was natural. Kepler argued that we are created in God's image as humans, and God allows us to understand the laws according to which he made the universe. And he wrote this in a letter, and this was his motivation to search for his laws for, I think altogether he worked for 20 years on them, amongst doing other things. So he never doubted that he would find those laws because of his Christian worldview. So yeah, so there are these philosophical questions raised by science that point to God, but of course they are not a proof. You can answer the questions differently.
How scientific then is it to believe in a God who can't be scientifically investigated? I mean, we can't put God in the test. We can't put God in the test tube and heat him up to 200 degrees Celsius and see what pours out, can we? I mean,
then he would not be God.
No, exactly.
I think it's very scientific to know the limits of science.
Right.
And you know, scientific questions are not the only meaningful questions. I mean, the question whether my husband loves me is not a scientific question, but it's a meaningful question to ask, and there is an answer for which I can give good reasons why I believe that he loves me, for instance. And so there are many, many questions that are not scientific, but that are good questions. And the question whether God exists is one of these questions. And of course, science can only deal with processes and phenomena within this universe. The question about the ultimate reality is a philosophical question, which is beyond science. And that's where we ask the question about God. So science is completely incompetent to tell us anything about God's existence or non-existence.
So when there are voices that say that science is all knowing and science is all powerful, they're mistaken, are they? That science has all the answers for life.
And for everything in the universe. You know, that's a very materialistic reductionist view. So it's this idea that a set of equations describes everything that happens in the world. And, you know, of course, every motion is motion of particles. Every motion is due to forces. So if you know all the particles, their positions, velocities, all the forces, and you have the laws of physics, of course, one could think that then these laws determine everything. But there's so many assumptions in this. you must believe that the laws are all comprehensive, that they are fully accurate, that everything is subject to them, and so on. And I prefer this view that the world described by physics is causally open to influences from outside physics. Mathematicians have these incompleteness theorems. They know that a set of axioms cannot give answer to every question. They can prove that that there are questions that cannot be answered within a certain mathematical theory. And it's similar in physics. There are questions that cannot be answered within physics, and our physical world is causally open to influences from beyond physics. I mean, for instance, my brain, when I think, certainly nothing happens in my brain that is in contradiction with the laws of nature. There are electric signals, there are chemical signals, but at the same time, hopefully I'm following the laws of logic, or I'm having a creative idea. And so there is influence from outside physics. And physics is complex enough and open enough to be open to these influences, to respond to them.
To what extent then you mentioned earlier about Kepler saw God as Kepler, the mathematician, saw God as the mathematician. I don't know who was being made in whose image there, but to what extent do the laws of nature reflect what you see as the nature of God?
They do not tell us much about God. I mean, there is this field of natural theology where you want to learn something about God from nature, and I think it's useful to think about what we can learn about God from nature, but it's by far not everything we can say about God as a Christian. I mean, we need God's revelation, we need to learn about Jesus and God's plan to redeem the world and so on. But nevertheless, the fact that there are laws of nature can tell us that God is reliable, that he is providing for us, that he wants us to be able to act responsibly, to foresee the consequences of our actions, because nature behaves in a law-like manner. So there are some conclusions we can draw about God, but we have to be careful, because nature has also the cruel parts and the parts that are hard to accept. So yeah, maybe that much about this question.
Okay, let's talk. You've talked about faith, your personal faith. What do you understand? And we're talking about laws. Let's talk about miracles, for example, because a lot of people think that miracles are something that actually is breaking the laws of nature, that God is somehow intervening with the normal schedule of things and is doing special things. Miracle, of course, is a word that's very loosely used. It might be a miracle that I passed my driving test, but equally a miracle that I didn't crash the car. When we see a newborn baby, we say, oh, she's a miracle. What do you understand by the concept of miracle?
I think there are several concepts and all have their validity. I mean, as you said, when something happens that we take as a special gift from God and that was unlikely, then we say it's a miracle, like a healing or whatever. Before that, I should say something else, because you said, okay, God intervening and interfering. So as if the laws of nature could run nature by themselves without, and God just standing at the side and watching what's happening. I mean, that's not the Christian view of God. God is running nature and sustaining nature all the time, according to the laws. So, and as I explained about my brain, I think, my brain is causally open to influences from an immaterial world, like the laws of logic. So I think the universe, nature, is causally open to God's influences all the time, to his guidance, to his healing, to his answering prayers. I think when God answers my prayers, he doesn't, so the laws of nature are not violated. Physics does not determine everything. So it's not that closely knit that everything is fully determined by physics. So there's lots of room for influences from beyond physics and for influences from God. But, as Christian, the resurrection of Jesus is the foundation of my faith. And I think that's clearly a violation of the law of nature that all of us die and remain dead. And here, I like to quote C.S. Lewis, in fact. In his book Miracles, he compares God to a poet, because a poet also has his laws for his work, you know, the rhyme and the rhythm. I don't know how you say in English.
Ganchen.
And when he deviates from his own laws when writing his poem, it can have two reasons. Either he's not smart enough to find the right rhyme, or he is very smart and follows a deeper law. He wants to convey a special message with this deviation from the normal law. And that's how I like to understand the resurrection of Jesus, because there's so much message in the resurrection of Jesus. I mean, it's a confirmation that he was the Son of God, that he really redeems us, that he is stronger than sin and death and everything. And it's the promise of the new creation in which all of us will participate one day. And if the resurrection of Jesus is the beginning of a new creation, you know, this new creation will not follow our old laws of physics. I think there will be some different laws. So it's very natural to me that in that case, or very logical to me that in that case, of course, the normal course of nature is not followed. Yeah.
So the resurrection then, science can, that, as you say, that goes against our understanding of the laws of nature. This was a dramatic intervention by God. It is, as you say, the fundamental truth of the Christian faith, that Christ was raised on the third day, according to Scripture. And science cannot, am I right in hearing you say that science cannot offer any insight or any explanation as to how resurrection happened?
No, how could we? I mean, it's a creative act by God. So it's something really new and unforeseeable. And, you know, why should science have something to say about unique events? I mean, science describes things that happen under normal circumstances. When, you know, there's this saying, ceteris paribus, that's a Latin expression. So if all the circumstances are as usual, then the events happen as usual. But here we have special circumstances, and science can say nothing about unique events.
You make that distinction then between the almost the limitation of science. It cannot add to that particular question of resurrection. What would you say as a scientist and as a Christian? What do you say that your faith gives you that your science doesn't?
Oh, a lot. I mean, I became a Christian because I was searching for the meaning of life. And I felt deeply that science cannot give an answer to that question. I mean, the question, does my life have meaning? Is there somebody who has a plan for my life? Or the question of hope for eternity, the question of forgiveness, the question of values, what is important? I mean, if things just happen according to laws of nature, it doesn't make sense at all. So certainly my faith gives me a lot that science doesn't give me. The two complement each other nicely, I think.
So they give you two different kinds of answers and two different kinds of meanings.
Yes.
And two different kinds of explanations. Barbara, thank you so much for your most helpful insights. We're going to take some questions from our very keen audience now. I'll try and put them in some sort of logical order, but I shall probably fail miserably. In fact, I've just lost the questions entirely from my screen. Right, here we are. Has your scientific career seriously challenged any of your personal beliefs?
Of course, my beliefs have been transformed to some extent. I mean, there was a time where I did not believe in biological evolution, I think until I was 31, in fact. Yeah. And so I believed in special creation of different species. But, you know, at some point I thought, as a scientist and as a Christian, I must be honest and really look at the evidence. And the evidence was so overwhelming that I accepted common descent of all life. I did not accept some of the explanations about how life evolves, but that's again a scientific question, which is very, very interesting. So I certainly changed my views in that respect due to science. And that in general, I would say science has enriched my faith because, it's a privilege to explore what God has created. It feels like, being able to have a glimpse at God's thoughts and God's ideas and God's creativeness. So certainly science has not made my faith weaker. I mean, of course, it has had an influence on my faith, but also my faith has had an influence on my scientific activity.
Yeah, in what way does it work that way, Rad?
When I decided to do some research and mathematical modeling on evolution, for instance, I just wanted to learn more about it, and my motivation was from my faith, or my faith shapes my expectations of what might be true or might be not true. I mean, we discussed the story of the Big Bang. At first it was the faith that made some people accept it more readily than other people. I mean, ultimately you have to look at the evidence and follow the evidence, but your faith certainly shapes your expectations of what you will find and what you will not find. I mean, I expect biologists to find many, many fascinating phenomena and complex things and a lot of creativity in life. So it's, for instance, because I believe in a creative and very intelligent creator.
We may well have touched on this since this question came in, but I'll put it from one of our audience. You say that the question, are we here by accident, is not a scientific question, but a philosophical one. Does your science ever influence your philosophy?
It goes in both directions. In fact, when I started to think and read and talk about faith and science, I realized that I really have to do a lot of philosophical thinking, because I think as a student, I accepted the reductionist scientific view. I studied elementary particle physics because I thought that's the physics that determines everything. I really believed that because it's often conveyed, maybe not always with words, but this message is often given. So I really had to rethink this, and I wrote a lot in the meantime about the topic of emergence, how phenomena cannot be reduced just to the particles or the parts and their interactions. There's also always the influence from the bigger context. There's this top-down influence in addition to the bottom-up influence. So yeah, I did a lot of philosophical thinking, being more critical about some naive philosophical interpretations of science.
Okay, let's move on then, because we've got lots here to work through in the next 10 minutes. Multiverse, people are interested in multiverse. If God created a multiverse, what would that tell us about God?
I haven't thought about it much because I don't believe in the multiverse. So okay. I think that would be, I would ask the question, what purpose might God have had, and it depends on how the multiverse looks like. You can also ask the question, why did God create so many galaxies and so many stars if life exists only at one place or at very few places? Why all these many galaxies?
Yeah.
I mean, this we understand that you need such a huge universe to have the possibility for an Earth. So.
I'm almost hearing you say we've got enough to discover in this universe without worrying about the possibility of multiverse.
Yeah,
is that?
I just think at this moment it's not a scientific question, because we have no access to other universes, even if they were there.
Okay, on the multiverse then, somebody asks, surely we postulate a multiverse because the maths drives us to this conclusion. Isn't it dishonest to suggest otherwise?
No, math doesn't drive us there. Okay, string theories, I think, naturally lead to multiverses. But string theories, I mean, I don't know how many different string theories there are. So, and the mathematics never drives us to a multiverse. So maybe because maybe the question is meant in the way that the constants are so special. So in this sense, they're unlikely, and that's why we need a multiverse. But this has a lot of presuppositions, namely that when a universe is formed, constants of nature are assigned to it randomly. But you don't know how a universe, how a constants of nature assigning machine works. What is the probability distribution?
Yeah.
So science tells us nothing about probabilities for constants of nature.
On the number combination machine then, or the generation machine, here's the next question. Right, could the fundamental constants of nature, of physics, be values other than the ones we know? And did God have a choice over these constants?
I mean, that's a very difficult question. I mean, what we can explore is we can modify the constants of nature, just change them by a factor of 2 or so, and just see that the universe doesn't work anymore. But maybe there's some completely different set of constants of nature. There's some completely type of chemistry that would still give complex universe. We don't know.
So I'm just, thank you. Here's the next one. Again, going back to what we were just talking about, the many galaxies, something like 200 billion galaxies or 200 billion stars or something I read once. Why did God create so many galaxies? It seems excessive.
Yes, God is a rich God. I mean, why did he create so many insects? Why did he create so many different flowers? So these why questions are not easy to answer. And who knows what's happening in other galaxies? We don't know. But anyway, you need such a big universe. You need the constants of nature to be like this in order to have all these elements being formed, in order to have stars being formed and burn slowly enough so that there's time for planets to be formed and life to develop. So in some sense, the universe must be as big as it is in order to allow all these processes that we need for life.
And this links into my next question from a member of the audience tonight. You talk about the universe being big. This is a question about the universe being old. And I read it to you. You believe the universe is billions of years old. Is your understanding of God any different to the medieval thinkers who thought the universe was just thousands of years old?
First, I think not everybody thought it was just thousands of years old. Some Greek philosophers thought it's eternal. Yeah. And I mean, thousands of years, that's as far back as we can think, because we have some historical traces. Or people used to have historical traces or traditions, maybe of the order of thousands of years. So that was their scope. But do I think differently about God and the universe? The people who discovered that the universe, but that the earth is old, they were Bible-believing geologians around between 700 and 1800. They found out that the earth has a long history. So that was long before, before Darwin and so on. So they were just convinced by the evidence, all these geological layers telling you the earth has an old history. There was an ocean at this place, and then there was a desert, and then there was a rainforest and so on. So of course, people asked them the questions, why this long history of the earth? Why so much life that has gone before we came? It's again a question about God's extravagance, about God's richness, creating many things and enjoying many things. It's, yeah.
The next question then. If the Bible gets science so wrong, why should we expect it to get the things we can't test correct?
The church father Augustine warned us to think that the Bible tells us anything about science and to claim that the Bible tells anything about science, because then we then we tell stupid things and people don't believe the important messages of the Bible. And Galilei, I mean, he argued a lot that the Bible doesn't tell us how the planets go. The Bible tells us how we go to heaven. It doesn't tell us how the heavens go, but how we go to heaven. So the Bible was never meant to give scientific messages. I mean, in the language that the people could understand, using the pictures, the views that they had, so that they could understand the message that was important to give them.
What scientific, we've talked about some scientific discoveries this evening. We've talked about Big Bang Theory, we've talked about evolution, or we've mentioned evolution in passing there. What scientific discovery has been the most difficult for the Christian faith?
That's hard to say. I mean, I think every scientific discovery is requires all thinkers to adjust their worldview. But I think it was also wholesome, because you could see that maybe your view was based on prejudices before. Certainly evolution posed challenges. I mean, there were Christians who accepted it right away, because they said, oh, that's great, that's very smart of God to make the life make itself, and not to create every species separately, but to give life the faculties to adapt and to change according to the environment. So that's far more parsimonious. And it also means that God is always involved, because there are always processes going on. It's not just God creating things initially and then letting it run forever, but God is always involved. He's always creative, sustaining all these processes, and in some sense giving us all our breath. And
you mentioned in our conversation earlier that God supports the laws of nature. Is there any science to back that assertion, or is it just a matter of personal faith?
No, it's a philosophical question. So the question is, there has been a conference a couple of years ago. What are laws of nature and why exist? I forgot the precise question, but laws of nature are a difficult concept, because they're not something material that can have an influence by itself. So how can these abstract laws govern the world? What gives them the power? They are just formula. So in this sense, you need some explanation. What makes matter obey these mathematical laws?
And what does?
Yeah, my answer would be God, and early scientists have given that answer. Somehow this answer is not very fashionable among philosophers of science, but they are really lost. They don't have real answers. Yeah.
Our last question for this evening then, Barbara, and we've had a very wide-ranging conversation. I'm very grateful for your time and your expertise and your input and your personal story as well. Do you think that science and religion, particularly Christianity, are good for each other?
Yes, certainly. I mean, yeah. You want a longer answer?
Yeah,
So they complement each other. The early scientists had this concept of the two books, the book of nature and the book of the Bible, where we learn something about God, from both books, and they complement each other very well, and they need to communicate to each other. They learn from each other. Overall, they complement and inspire each other. Of course, sometimes they also fight, or they have to discuss things, because not all answers are easy, and I don't want to give the impression that I have all the answers. I mean, there are many interesting open questions that will keep us busy for a long time, I think.
Thank you so much for your time tonight, Barbara. My guest today has been Professor Barbara Drossel, a theoretical physicist at the Darmstadt Technical University. If you would like to watch this again, or to catch up with earlier conversations from the two series of Questions of Our Times, please visit the Christian Evidence Society YouTube channel, Evidence for Faith. And the 4 is a figure 4, Evidence for Faith. At the same time next week, I shall be discussing whether we are alone in the universe and whether the universe is alone in the universe with astrophysicist and space discoverer Dr. Jennifer Wiseman. Please don't leave us alone. Please join us. Thank you for watching. Goodbye.